Hello, hello, hello. Hello everyone, I am Rajiv Ranjan and I will be conducting this live interaction sessions in the field of field structural geology course. So today is the week 1 live session. So let us start. So these are the course outlines that you all must have you know seen in the structural geology, field structural geology course on the NPTEL websites. So the week 1 consists introductions, tools, field locations, measurements, plotting the data. Week 2 includes primary and secondary structures, basic lithology structure mappings. And week 3, you will be studying about ductile deformation, superposed and overlapping relationships. And in the week 4, you will be learning detailed deformation, strain measurement, and regional deformations. So let us start with the week 1, and I will give you the summary of the week 1, what you all have been through in the week 1 lectures. So the session started with introduction of the field geology and what is its significance. And then we learned the two types of field geology. And then we learned about tools that we take to the field, all the various types of the materials that is important in the field, like hammers, measuring tapes, etc. Then in the next lectures, we studied about the locations, the field locations where you have been to the places virtually, such as Ghatshila, Dalungar, Tepuldanga, and Bodi. And then you will learn how to take measurements, both planar and linear features, and plotting the data. So let us start with the problems of the each of the sessions. Okay. So I have prepared this presentation in such a way that I will be covering questions based on the theory you have learned in the first weeks. And while solving these problems, you will you will get the revision for all this previous lectures that you have been, and you will clarify your dots while solving. And if you have any dots during the sessions, the live interaction sessions, you can raise your hands or unmute yourself and ask. Hi Minakshi, can you hear me? Hello, can you hear me? Minakshi, am I audible to you? Okay. One second. Hello, am I audible? Okay, I think I am clear, right? Hmm. So, the first question, very basic question, that geologists carry out field work in option A. Sorry, I'm sorry for these options. B, C, D, E. Okay. So, option B is regional scale, outcrop scale, microscopic scale, or atomic scale. So, can you tell us the answer? Which one do you think? Why? Where do the geologists, on what scale geologists carry a field work? Nakshi, you can text, you can chat, you can write your answer in the chat box as well. Okay, so I will go through one by one options, why the option is not correct or incorrect, or which one is correct. So I will go start from the last one. So atomic scale, we know that in the field, when we go to the field, we do not look at atomic scale, right? Atomic scale you have to do. No, it's important in the material science engineering and atomic scale when you do TEM, transmission electron micrographies and all. Then you try to see on atomic level and the microscopic. So this is incorrect. Option D is microscopic scale. So we know to study on the microscope level, micro level, what we do is we look under the microscope, which is not possible in the which we do not do in the field. So this option is also not correct. Outcrop scale, when we go to the field, what we try to do, we try to find the first thing we try to see is that whether any outcrop is visible, exposed somewhere. So we always look for outcrops in the field. So this seems to be correct answers. Okay, let me go to the first one, regional scale. So we generally do not do field regional scale, because when we do talk about regional scale, it comes about kilometers, tens and hundreds of kilometers. So what we do is we try to look for outcrops, exposed outcrops, and study several outcrops in a location in a regional scale. So what we do, we study an outcrop level, and then we interpret on regional scale, and then we also do microscopic analysis or atomic analysis. So this is the correct answers. Okay, we'll move to the next question. Which one of the following is an igneous rock? Sandstone, migmatite, basalt, phyllite. What do you think? Okay, so once again we'll start from one by one, seeing all the options. So sandstone, we know what is it? It is a sedimentary rock formed by the lithification of this sand particles. Migmatite is, we know that it is a composite rock or mixed rock, which we also call it, which has the signatures of what? Both igneous and metamorphic signatures, right? So this is incorrect, this is incorrect. What we are looking for igneous rock. So basalt, we know that it is an igneous rock, and it is plutonic igneous rock. Hmm? And what is its complementary? Sorry, it's a volcanic rock. And it's the complementary, if it is solidifies the composition beneath the earth, which what we call those rocks are plutonic, and the complementary of basalt is gabbro, right? So it is a volcanic rock. So this seems the correct answers. Okay, phyllite, we know it is a metamorphic rock, right? We all know. I hope you all are clear. If you have any questions, please raise your hands or unmute yourself and clarify your doubts. Okay, so we'll move to the next questions. Structural geologists mainly investigate A. Igneous processes, right? B. Deformation structures. Option C. Geochemical signatures in rocks. Option D. Mineral composition in rocks. So, what do you think? Structural geologists focus mainly on what? Tell me. Does a structural geologist focuses on igneous process? No. This is the job of mainly the job of petrologist, right? Option B is deformation structures. So this is something, the deformation structures is what structural geologists are interested. Okay, so this is where we are structural geologist is interested. So they're mainly interested in deformation. So as soon as structural geologists go to a field, their eyes catches any structures if they observe any deformation in structures, right? And these geochemical signatures in rocks, they're mostly, geochemists are interested. I mean, we are, but we are not. As a structural geologist, our main investigation is on the deformation. These are supported, right? Supportive evidences. And mineral compositions, we know these are for mineralogists. So, option B is correct. We'll move to the next question. Which of the following is used to measure dip and strike? Option A, diagonal scale. Option B, GPS. Option C, clinometer. Option D, measuring tape. So, okay. So from here we can see measuring tape. We cannot, measure dip and strike, right? So it's similar. It's incorrect. Clinometer is something that you know which we learn, what, that we use. You must have seen, in the lectures, that clinometer is used to measure dip, and because it has all the necessary equipments. GPS, we know that it is mainly important for it's mainly important for precise locations. you know it's important for locating, right? Locating, right, ourselves. And diagonal scale, it's not something, it is an engineering scale which is used for angle measuring angle. So it's something appears like this, and there will be lines, right? So this is how it appears roughly. um my drawings are really bad, so please bear with that. So from here we know the answer is clinometer. So if you have any doubts, please raise your hand. Which type of map is used for geological field study? Demographic map, vegetation map, topographic map, or cadastral map? So we know demographic map is a map where, in which population It's all about populations indications. I mean, maybe it's density, you know, total population. So overall, it's related to populations. Vegetation map, it deals with vegetation, right? So, and topographic map. So this is incorrect. This is incorrect. So topographic map. What is a topographic map? It includes. What does it include? Topographic map. Tell me. Anybody? What is a topographic map? Can anybody tell me? Hi Sanat. Can you hear me? So topographic map is basically deals with. So it has, in a topographic map you will see, you know, countries, states, river, ponds, etc. So it includes all such topographical features. So in general, in a geological field, for us, we use topographic map. In a cadastral map, can somebody tell me what is cadastral map? It is
Village
a
map.
map. You're not audible, Sanat. Can you speak louder?
Village map.
Wait a second. One second. One second. One second. Let me.
Village map or small scale map.
Image map. Are you talking about image?
Village.
Uh, what does it contain?
Road, then village boundary,
Hmm.
and the prominent features like post office.
So you are very close. You are very close. The main purpose of cadastral map is to demarcate what, mainly lands, right? Land areas. So you said right that village, or suppose you have, if you have fields, if you have some land in your village, your own land, so you must have some records. So it is important for what, land record purpose, right? So we know, so that is why option C is correct. Okay, so we'll move to the next question. So Sanat, you try to solve this question. So I will read out: the strike of a bit dipping 30 degree towards north 45 degree west. So try to find what would be the strike of a bed whose dip is 30 degree and direction is north 45 degree west. So you know try to find it. I will give you some time. So try to find it. If once you are done, let me know. So what I will do in the meanwhile, I will do for you. Okay. So try it. There are several ways which in which you can solve this. So use your own way and let me know the answer what you are getting. Are you trying it?
No, I don't have the this one with me. Instruments with me.
You don't have any pen paper?
Yeah, I don't have present.
Okay, okay, okay. It's fine. It's fine. Okay. So let us try here. Okay. You can see it's my screen, right? So, so tell me, the dip amount is 30 degree and towards is north 45 degree. So you know how to plot, right? Attitudes, structural data. in a coordinate system, Sana?
Hmm.
You know,
Yeah,
right? Yeah,
yeah.
good. So north 45 degree west.
Become like
So it will come in which one? This one?
yeah.
So like this, I'm drawing it roughly. So it will be 30 degree, right? I'm just, bear with my drawings. I'm really terrible at drawings. So this is 45 degree. So this is north 45 degree west, right? So this is the direction and dip amount. So what will be the strike? It will be 90 degree, right? From here, it will be like somewhat like this.
Yeah.
Yeah. So this was a strike. So what do you think? What would be this value? Tell me first here. Tell me this one. What will be the value?
Approximately it is 45.
0.45, right?
Yeah.
And this will be this part
So same 45 only.
225, right? So from here we can see that option A is correct. Right? So there is another way you can solve it. You been through the lectures of the week one, or if you know, so you know right hand rule. Do you know right hand rule?
Huh?
Yeah. So what you can simply do is from dip direction amount, you can simply add 90 degree. You will get the strike, right? So if you add 90 degree to 45, it simply comes not 45 degree east, which is none other than 0.45 degree, right? Okay. So we'll move to the next problem. Tell me, what do you think? The Chaibasa formation consists of which type of rock units? Option A, igneous volcanic rocks. Option B, sedimentary rocks, shale and sandstones. Option C, metamorphic rocks, mica schist, quartz, granulates. Option D, marine carbonate rocks. What do you think, Sandhu? Any guess? No guess? You can respond either, it's fine. We will together solve this question. Okay, so what do you think? Option D, about option D. Is it correct? So if you see here, it indicating marine carbonate. So we are talking about here the Chivasa formation, right? So it's not related to any marines environment. So it is mostly have metamorphic rocks. And in the field we saw, at least in initial understanding which we know, is that it's a mica schist. It contains mica schist, quartz, and granites.
Okay.
So what do you think? What is the right answer? Which option?
Metamorphic rock.
Right. So option C, and we have seen right in the introductory lectures also, Sir has talked about. If you have seen the lectures, Sir has very briefly talked about this micas and the quartz bands, right? Those three bands. Yeah. Okay. So the next question is the oldest rocks from Singam Cratons are Chaibasa formation, older metamorphic group, older metamorphic tonalite gneiss, or Mayur granite. What do you think?
older metamorphic group. I guess.
Hmm. You have seen this stratigraphy, right?
No, actually, I have not gone through the syllabus.
Oh,
The first
we have
first
not.
three courses. Yeah.
Okay. So in the lecture, you will see this is the stratigraphy of Singham cratons. Very
Okay.
simplified stratigraphy. Very simplified. So here, if you see, the oldest one is older metamorphic group. Then comes this older metamorphic to non-lightness OMTG,
Support. Yeah.
and then comes different, other groups like. Can you? What is your name? Just joined. Swairakappam. Sorry, I'm not able to pronounce it. Can you tell me your name?
Sorry, Singchokum actually. Kwapam
Jing.
Singchokum.
Okay, sorry if I am not able to pronounce your name. So I will call you Shing. Would
Okay,
you
sir.
find
Oh,
Shing?
yes, sir. Yes, sir.
Yes. Okay, nice. So we are solving some problem Shing here. So be with us. And if you have any doubts, please raise your hands and or unmute yourself and ask questions. Okay, so this question we were discussing that what was the oldest rocks of Singham cratons. So these were the options. So that's what we were discussing. The oldest formation or oldest rocks in the Singham cratons is older metamorphic groups. So if we have seen lectures, there sir has talked about this is stratigraphy, very simplified stratigraphy of Singham craton. So here we can see the oldest rocks is oldest metamorphic groups, and then comes with OMTG, then Singham granite, then peletic, arenes, and then quartzite, this Dhanjori, and then it comes with very latest Mayurbhanj granite and very recent dikes. We saw in the fields that there are numerous of dikes and sills, which is very recent. Okay, so we'll move to the next question. Okay, please read it. I will read out for you. Tell me the correct answer. What do you think? Which option is correct? Choose the correct option that defines azimuth. Hmm. Okay. Any guess?
Option one.
Option A. Okay. What about Shing? Okay, so we'll read out. The angular reading with respect to the magnetic north direction measured on a horizontal plane. Okay, this seems to be the correct answers. Or other than this, do you see anything? So there is another horizontal plane. So very simple way to understand this is azimuth. So as soon as we talk about azimuth, we should understand that we are measuring on a horizontal plane. On a horizontal plane. So there are mainly two types of measurement if we talk about. So one is azimuth and second is inclination, right? So when we talk about azimuth, so it is measured on a horizontal plane with respect to obviously north direction. But when we talk about inclination, what does it measure? It measures on a how much is the inclination means these angles. So suppose this is the so this inclination is called. So there are two types of air. So I will show you this place. This the lectures. I have taken this pictures from the lecture series. So you can see the first is azimuth and the second is inclinations. So as is measured in a vertical plane. The azimuth, it's in a horizontal plane and in a vertical plane, right? So what we do here, if you see these blue lines, blue shadow, so this is measured on a vertical planes. So there are two types mainly. So the inclination is measured on a vertical plane and azimuth is measured on a horizontal plane. So remember this. So we know strike and dip direction, these are the things that we measure on a horizontal planes, right? So we will go through more a number of problems, you will understand this. Okay. Okay. Once again, next question comes it's related on the same questions. Not exactly, but yeah. Please read it. Choose the correct statement. Is option A, strike is the trend of intersection of a planar feature in a vertical plane when projected on a horizontal plane. Option B, apparent dip direction is always at 90 degree to the strike. Option C, the apparent dip is always less than the true dip and plunge of the plane. So from here we can see that option D is incorrect. Why? Because plunge is not measured for a plane. Plunge measure is measured for lineations, right? And for a plane, measure dip, right? Or strike and dip directions. So the apparent dip is always less than the true dip. This is what is very important when we learn about the concepts of dip, the attitudes of the beds, planar features or linear features. We learn very basic concept such as true dip and apparent dip. So if you see, true dip is always measured on a perpendicular to the strike. So suppose this is the strike, so the tip is measured in a perpendicular. That is why dip direction is perpendicular, right? However, so I will go back to the previous slide, and if you see here, so this is at this vertical degree, the the purple, the blue, plane is at 90 degree to the strike. However, if we measure at some other plane, suppose at 70 degree, 60 degree, if we measure something on 70 degree plane, what will happen? This will be called its apparent dip, and this is what we call it true dip, right? So the apparent dip will always be less than the true dip, because true dip is measured at 90 degrees, and in all other directions this will give us the apparent dip, right? So that is why option C is correct. If you look at option B, it says the apparent dip direction is always at 90 degree to the strike. It's not correct, right? Right now we learned that apart from 90 degree to the strike, all the other directions, the dip amount or the dip will be
In between 0 to 90 degree.
so in between 0 to 90 degree, whatever in that plane if we measure inclination, that will be, or dip, that will be a apparent dip.
True dip is always perpendicular to strike direction.
Apart from this perpendicular to the strike direction, so that will be apparent dip. So apparent is always greater than here. If you see option B, apparent dip direction is always at 90, which is incorrect. Okay, look at the first option. Strike is the trend of an intersection of a planar feature in a vertical plane when projected onto a horizontal plane. So we learned recently what, that strike is measured on a horizontal plane, right? Not in a vertical plane. So that is why option A is incorrect, option B is incorrect, option C is correct statement. Okay, so let us try to solve this question. In field, you measure the inclination of a plane which is oblique to its strike. So you have actually, what did you measure that? Option A, trend of a plane, true dip of a plane, apparent dip of a plane, or plunge of a plane.
Option C,
Option
apparent.
C, apparent dip of a plane. Right, you have rightly answered. So it's very basic that we have seen for the last couple of questions. Okay, so I don't think there is anything to discuss here, right? Because we know that this oblique to the a strike from 0 to 90, it will always be apparent. Trend, it's not true. Why? Because you are measuring inclination, not azimuth. Trend is azimuth, right? True dip is at 90-degree, not in between. And you know, plunge of the plane, we know plunge of the plane is at, not oblique. Okay. Okay. Next question. The following orientations were recorded in a field: 270 65 degree northwest, 90 degree 45 degree south, 180 degrees 76 degree north, and 220 degree 30 degree southwest. So which of the following orientation is correctly recorded? So these are the four data that has been given. So you have to see and select the which one is the correct data that is has been recorded of a plane. I mean, okay, so let us try solving it. North, south, east, west. So 000, 090, 180, 270. Okay, so we'll try to look at the first option. 270 degree 65 degree northwest. Okay, so 270 degree is the strike. So 270 degree, where it will be like somehow like this,
200
right?
degree 33 degree southwest is correct.
Okay, okay, let's go one by one, huh? So the first option is 270 degree. So this strike will be like this, hmm, and 65 degree northwest. So northwest. So it is not possible to have dip direction like this. Ideally, it should be towards 000, right? Means towards north. So this is incorrect. Yeah. So now, let us go check option B. So option B is 090. So again, it's same, and it's 45 degree south. So this is the strike, and 45 degree towards south. 45 degree. Let me one by one, huh? Try to. So what do you think? This is correct or wrong? Okay, option C. Let's see option C one. Then we'll talk about which one is correct or which is not. So I am seeing that this is also a correct option, but we will check. Huh? Then we'll move this. Where did I go? Where did I go? Where did I go? One second. One second. One second. So option C is 200 degree. So it will be around somewhere lies like this, and 30 degree south west. So what do you think? This is correct?
It's not correct.
right? So which option is correct? Okay, let do the try to solve that. And
B is correct.
B is the correct option. Okay, let's try the D also. Option D. So it says 180 degree, 76 degree. So let me change the color. 180 degree means this, north south, north south. Okay, let me solve here. 180 degree, and towards 76 degree northeast. So it's saying it is around like this. This is raw. So option B is correct. Right? Did you understand? Where did you go wrong?
Yeah.
Yeah. Okay. What will be the deep and dip direction of a vertically dipping of a fault plane having a strike 260 degree? So what do you think? So what will be the dip and dip direction? So which the bed is dipping, the fault plane is basically dipping vertically, huh? And having a strike of 260 degree. So what do you think? Let's again do this. Tell me. So your strike is given. What? It's something very close. It's like this 260 degree. Hmm. And it dipping vertically. So what do you think? What is the correct option? Are you able to see?
I am able to see. It is 60 degree southeast and 60 degree northwest. These are the two direction it is possible.
Okay, so either this will be like this. I mean, see, simply option A and option D is wrong, right? In the very first step, you can just negate these two options. Why? Because you can see here it's vertically dipping. That means it's either option B or option C, right? Because 60 degree is not the correct option. It will be 90 degree because it's vertically dipping, right? So now the question comes whether it is north northwest or south southeast. See, here comes the role of right hand rule. So right hand rule says that if you have the direction, which direction? Strike or dip direction, what you should do, add 90 degree and you will get the, what you will get? You will get the strike or dip direction of the plane. So here we have given 260 degree as the strike. So try to add 90 degree from this. So what will happen? It will go somewhere like this. I mean very close, right? So this is what? North northwest, right? Right?
Hmm.
So that is why option, because it seems otherwise you will be confused that it is possible that south southeast would be correct. So this is not possible because why it is not
Okay.
correct? Because according to right hand rule, this is not correct. Because if you add 90, it comes around. If you subtract 90, then it will be like this, which is not. So that is why here we need to apply right hand rule. Okay. So that is why we use generally when we go to a field, we always try to use right hand rule, and we place our hands and we try to see where where is the strike, and then this is the strike. So plus 90, if we add 90, so we'll get the dip direction. Or if we subtract from the dip direction, very simple way, you can what you can do is it's add, so you will get this. So, but in it's that the original, the convention is to add from the strike, add 90 degree, you get the dip direction. Okay, move to the next question. This question says choose the incorrect statement. Remember, incorrect. Incorrect statement. Option A, apparent dip is always less than or equal to true dip. Option B, strike and dip directions are perpendicular to each other. Option C, plunge is the angle between the line in an inclined plane and the horizontal in a vertical plane. Plunge direction and trend of alineation can have different values. Try to find the incorrect. What do you
D is wrong.
D is
Wrong.
wrong. Why? Why do you think? C. Okay. So we'll go one by one. So this is not correct, right? It cannot be equal to apparent dip, cannot be equal to true dip, right? Or equal to true dip.
To 90 degree.
It could be, right? It could be. Why? Because if it becomes 90, so same, the apparent dip will become the true dip, right? The opposite is not true. True dip will not be equal to apparent dip. I mean, it could be. So it's like,
True dip never equal to the apparent dip.
right,
But apparent dip less than or equal. Use the
equal
word
to,
less than or equal.
that's how it will work. So that is why it is correct. So option B is strike and dip directions are perpendicular to each other. That is very basic thing that we know. It's true. Option C, plunge is the angle between the line in an inclined plane and the horizontal in a vertical plane. So we saw which one? This photo. This, if you remember. Be clear. Hmm. So we saw what? So it is on a if you see this blue plane, so this is vertical plane. So this is measured between so if you see, this is an inclined plane and this is a horizontal plane. So what that is what is mentioned here. Sorry, here, that plunge is what? Angle between in an inclined plane and in a horizontal vertical plane, and the horizontal, and that is measured in a vertical plane. So that is why this is true, this is true, this is true, this is incorrect. So option A, B and C is correct and option D is incorrect.
Yeah.
Okay, pitch of a linear feature is equal to 90 degree. So what would be the plunge of that linear feature? Tell me. Option A, true dip. Option B, trend. Option C, bearing. Option D, strike.
Is it option C? Bearing.
Okay. See, when you are trying to solve the problems, and especially if you're trying to solve multiple correct or MCQ based, basically MCQ based, then you try to see all the options and try to understand why it is such, or why I'm having this C answer. So can you tell me why you are thinking option C is bearing? So okay, before that, let me ask you. So you understand rake and pitch, right? Pitch. So if you see here, let me draw a basic, very basic diagram. Hmm. So suppose this is a bed, and you have what? You have, this is, for example, this is north. Huh? So you have alineations like this. You have alineations in this direction. Hmm. And the rake, the pitch, do you know how pitch is measured? I have kept some slides. I don't remember where. I have kept one slide where I will show you all these different attitudes. So the pitch is measured on the fault plane itself. So this is the angle, which is 90 degree. So this is on the fault plane. When we measure any lineations on a fault plane, so the angle between this strike and this the lineation is the rake or pitch. So now if you see, the plunge of that linear feature is equal, since it is at 90 degree, what do you think? The plunge will be what? It is never is going to be trained, right? Because trained we need to project, right? To obtain a trend, we need to project this lineation on where? On this horizontal plane. On this, on a horizontal plane, which is not here, right? Which is not the case. So this is wrong. And trained and bearing, if you know, trained or bearing is nothing but the same, right? You know this, right? Trained and bearing.
No.
Hmm. So this is not possible. Let's look at strike. So if we know in a linear feature, what do you measure? What do you measure? Trend plus what? Plunge, right? So these two things we measure for linear feature. And what do you measure in a planar feature? What are the things you measure? You measure strike, right? Dip, then dip direction, right? So strike is not something that we measure in a linear feature, right? So this is incorrect. Important thing is here is that if you can see, this lineation is at 90 degree to the strike. And what is that at 90 degree? What do we measure? When we measure a plunge, that will be equal to what? True dip, right? Because true dip or true plunge, or in other way you can also call it true plunge, or we do not call it, we generally call it plunge only. But at 90 degree, this will give us the true amount. Do you understand now? So that is why option A is the correct answers. Did you understand?
Okay.
You have any confusion?
No. No.
Okay, good. Okay, now try to solve these questions. This will help you to understand the stereographic projections. You have learned the stereographic projection, right? You have some idea, basics.
No. No.
No stereo. Okay. So I think, okay, let me go through. let me take you through the stereographic projections. So in the stereographic, have you seen a stereographic projection like this?
No,
No. Okay. So I would suggest you to go through the week one last lecture. There Sir has really explained very in a very good way, in a nice way, what is radiographic projections, and what do we do, how does it gets produced. So in simple way, I will tell you the stereographic projection is a way to represent your 3D data in a 2D plane. Hmm. And it's a little bit detailed. The procedure is a little bit detailed, so I'm not going to get into that detail because it will take a lot of time to explain you that. So in brief, you try to understand that this is a stereographic projection. So if you see, so here if you see north, which is 0 0, here you see east, here you see south, here you see west. And if you see here, it is divided into 0 to 90, then here 0 to 90, then here 0 to 90, and then again here. So here is 0 to 90. Or you can write in this way also: 0 to 90, 180, 270, 270, or 360. You can write this way also. Okay. So it will be a little bit difficult now for you to understand, but I will try my best to understand, make you understand. Okay. And then what we do is to measure. It will be very difficult. I think I have to explain the procedure. I have to explain you very briefly the procedure. Let me one second. Let me give me 1 second. I will show you something. Okay. Video. Huh. So remember, for the time being, remember that in a 2D plane, okay, this is a bit difficult here. So this is actually the projection of a lower hemisphere. Suppose if you have a hemisphere, yes, from where shall I show you? Give me a second. Give me a second. Give me a second. Wait. I will show you. I will share with you the screen where I will very briefly try to explain you stereographic projection. So they try to, otherwise it will be really difficult for you to understand this. So I will request you to please go to the lectures, before coming to the next live sessions. Okay. Okay. I will share with you. You can see the slides, right? Yeah. Sanat, can you see the slide? Hello. Can you see my slides? So okay. So look at here. If you see here, so this is a sphere. This is a sphere. So this is a sphere, right? And this is a equatorial plane. This is a equatorial plane. So what do we do? What we do? So if you see here, it is a line. So you can see this is the line. And when we pass to the hemisphere, this is cutting in two places, here and here. right? Or if you see here, option play point B and point A. So you can imagine that when you pass a line in a sphere, it will cut on the two sides of this sphere, right, on the diametrically opposite way. So now what we are doing, we remove the top surface. So imagine the top surface, the half the southern, you can say the upper or southern northern hemispherical sphere has been removed. So now you can see the lower hemisphere. Huh? So here option B, point B is marked. So it will also intersect somewhere, right, on this projection plane. This is the projection plane, right? Somewhere it will project. So now what we do, we try to join what this point B to the zenith, the top of this sphere, north top. Hmm. And the point at which this intersects on this projection plane, what will be that? That will be the representation of the lineations on a stereographic projection. So this is what we call it, stereographic projection. So this is how we plot a point on a stereographic projection. So this is how it appears. You can see this point D. Huh? So there is two things. So this is what it gives the bearing or the trend 000 180 270 or 09090. So if you see, this is lying somewhere around 80 degree. So the trend of this lineation is 80 degree. To measure the plunge, what we do, if you have seen anywhere, if you don't, so what we do, we try to take this point in the north point. So it's difficult for you here it will be difficult for you to visualize, to the north, and then try to measure 10, 20, 30, 40, 50, 60, 70, 80. So the amount from here to here, the amount of degree will be the plunge. So since it's very close to the center, it will be very, it will be very, the dip amount will be, the plunge amount will be high. Now look at a plane, how it is projected. So this is again, we have, you know placed a plane in a sphere. Now the top hemispherical part has been removed, so the remaining is this. So you can see it is intersecting in like this. So you can imagine, when you if you put a plane in a hemisphere, what it would be, it will be like circular arc, right, in such a way that it will cut this. So you can see from here A to B, it is intersecting. So remember this plane. So this is the plane, right? The orange color is marking. The orange is the plane is cutting in this sphere. So remember this. So now what we are doing, the same thing in the case of lineation, we used to connect to the zenith. Now since we have, some, semicircular arc, so we are trying to join each of this arc, to the top. So what will happen? So the resultant would be what? So the resultant would be, if you cut here, you will see something, you will see like this, right? If you just trying to intersect all this lineation, so it will form a dot dot dot, this curvy line from A to B. So this is what you see here, right? Dot 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 dot. This is has been the places that intersects on the projecting plane. And when you try to this is how, when you, this is from the side view. From the top view, if you look at the projection plane, this is how a plane appears. and this will give this point and this point A and B will give you the strike, and this will give you the dip angle or angle and direction. So basically this will be the dip amount, sorry, dip amount and dip direction. I hope little bit you have understood, right? Sorry, you now must have some idea, basics idea. So this is the plan view and this is the side view. This is how it appears from the top, and this is how it appears from the local the side view. So this is the dip amount. So here if you see 90 minus theta, and this is theta, alpha. Here it is mentioned as alpha. So this will be the your dip amount, and this will be direction amount. So we will try to solve this problem. You will understand. Now you will understand. Oh. So I will share with you now the question which we started with. So now try to find this. The lineation is marked on the stereo end. The trend of the lineation is what? Tell me the trend of this lineation of point A. Now just we now studied. What do you think? Guess? Any guess? Okay. So let us try solving it. So I just told you that from the north direction, this will give you the trend, right? Trend. So it's simply 10, 20, 30, 30, 40, 50, 60. So it's simply 60 degree is the lineation's trend, right? If we talk about plunge, so if you see here, it since it is lying on this boundary, right? So let me take you through again. Okay, fine. So since it is lying on this circumference, that means that there is zero amount of plunge. So if somebody asks that what is the plunge amount here, so it is 0. Suppose it would have been here. If it would have been here, the plunge amount would be almost 10, 20 and 30 degree. So it will be around 30 degree. So like that, that is how we try to understand the stereographic projection of a plane, of a point, sorry. Yeah, I hope you are getting little bit. I can understand it will be difficult because you have not been through the lectures, but I will try my best to help you understand. So the next question I have a little bit difficult ones. So try to solve this question. Try to first understand this problem. So here I have given you 4 lineations, L1, L2, L3, L4. And this is plane A. Suppose this is, suppose this is plane A and this is plane B. So this is one plane and this is another plane. So this on this plane there is one lineation and 2 lineation, and this plane B, L3 and L4, there are 2 lineations. So the question is, which of the one of the lineations plunge amount will be equal to the true dip amount? So for true dip amount, you need to have your bearing 90 degree. So I'm giving a hint. So try to find of a lineation which has the, you know, 90-degree dip amount, 90-degree plunge, or 90 degree. You can see on the plane also. You will try to see. If you try to see, you will understand. So if it's okay, let go one by one. If you see L1, this is the L1. So try to see the bearing is 30 degree, right? And strike is 000. So it's simply you can see the rake. So we learned there also, right? We remembered if the rake is 90 degree, that means it is representing true. You remember this, right? This one, right? That if the rake amount is 90 degree, then it means it is representing the true dip. So very similar to this concept, but it's in a stereographic projection. So here it's rake is one more thing I will just try to make you understand. When we talk about rakes on the stereographic projection, we try to measure the rake from here on the fault plane 10, 20, 30. So here the rake amount is 30 degree. And if you talk about lineation 2, 40, 50, 60 degree, right? Bearing this, I have put very simple because I have kept it at n a 9000 and 0180 pay. So it is very simple. Let us try to see the lineations. 3 here, the bearings and the rake is 40 degree. Here if you see L4, it has bearing of 90 degree and rake of 90 degree, and we studied a couple of slides earlier. Then when rake is 90 degree, that means that it is indicating true dip, right? So what do you think? What is the correct option? Am I audible, Sanat? Sanat, am I audible? Okay. So very from this, what I have explained, it's very clear that L4 is the correct option. Why? Because it has a rake of 90 degree. It has a bearing of 90 degree. So it's important, the rake. So it has a 90-degree rake. So that means it is representing the true dip. Okay. Let's move to the next question. Very similar question. So what do you think? Which of the following relation will give the highest plunge amount? So think for a couple of seconds. I will give you 30 seconds to think about this problem and then try to understand. So I have discussed the same things in the previous slides. So try to understand the question, which one of the lineations will give the highest plunge amount? It's very similar to this question. I have discussed everything in the last question. You just have to think a little and then you will understand. So what do you think? Lineation 1, lineation 2, lineation 3, or lineations 4? Which one would give the highest plunge amount? I told you how to measure plunge of a given lineation. So be here for, I will be back in 10 seconds. So here you can see the highest plunge amount is try to measure. So here it is around 20 degree, here it is around, you know, more than 20 degree. So in the ideal way to measure plunge is to shift this lineation on this north-south vertical, north-south direction, and then we try to measure the amount of plunge from this 000. So if you took this, so this is the small gap, and you see this is a larger gap. So it's obvious that lineations 2 will be higher plunge. But if you see L3 and L4, L4 has the largest plunge, and it's very obvious that this fault plane has tip of 20 degree and this fault plane has this 30 degree. So it's very obvious that this the lineation 3 and 4 will have the highest plunge. So to eliminate one L3 or L4, we have to see the amount of plunge in L3 and L4. So it's clear from here, if you try to move to this north south direction, we have small gap here and we have larger gap here. So if you try to move in the north south direction, we'll have L4, which will give us the highest plunge amount. If you have not understood, please let me know. I will be very happy to help you understand these questions. Okay. So we have seen the highest plunge amount. Now it is question that which one of these will give the lowest. So the lowest plunge amount we discussed, right, that this will have either L1 or L2 will have the lowest. So when we move this L3, L1 and L2 in the north south direction, we'll see the lesser gap will give lesser amount of plunge. So similar, that is why L1 will give us what? The lowest plunge amount. Okay, so we'll move to the next question. Which one of the lineations will have the lowest rake amount? What do you think? Now I told you how to measure rake, right? We measure on the fault plane from the north, from this strike direction. So 10, 20, 30, right? L1 has 30, L2 has 40, 50, 60, L3 has 10, 20, 30, 40. So these has 40, these has 60, these has 30, and L4 has 90. So what do you think? It's obvious. It's very simple, very easy. That L1 has the lowest rake. And highest rake would be what? Option L4, right? Okay. This I have just kept to make you understand how stereographic projection is used. I have already explained this. Okay. Let's move to the next question. So according to right hand rule, the dip direction is determined by adding dash to the strike. So this also I have discussed in the class in this live session only in the beginning. So the right hand rule tells us what the dip direction is at 90 degree to the strike, and this is dip direction. So what? So what is the question? We have to determine dip direction. Strike is given. So from strike, we will add simply add 90-degree and we'll get the dip direction. So option B is correct. If you subtract it, it will not be the right answer. So this is wrong. 180 degrees is completely wrong. 1 minus 180 degrees complete. So both will give us the strike only. Right? What is the stereographic projection primarily used in structural geology? I have also discussed this question. Tell me. To measure the age of rocks? No. Determine the mineral composition of rocks? No, right? It's nothing related to the mineral composition, right? To represent 3D orientation of planes and lines on a 2D plane, right? The stereographic projection is to represent 3D data in 2D plane. Orientation data? No. To calculate the density of minerals? No. So option C is correct. In a stereographic projection, what does the great circle represent? Tell me. So we saw this stereo projection. So this is the long ones, and this is the smaller circle. This is the longer circles. So what does this represent? This is the question. Lineations? No, because it has only a point. So this is wrong. Trace of plane is the correct answer. Orientation of a fault? No. It shows the trace of the fault. The intersection of two planes? No. So option B is correct. So next question is, what is the pole in a stereographic projection? So what do you think? Pole. A pole is something. So suppose this is not. This is just to make you understand, help you understand. Now, so this is stereographic projection. So suppose you have one planes. You have one trace. So this is the. Hmm. So this is. So if you have a bit like this, so this is the center. So if you move 90 degrees from this point, and what we do to plot a pole, so this pole is very important when we have, if you have a lot of data, hundreds of data, so it looks very clustered, right? It's very, it is not good way to represent data. So that is why in case of very large data, what we do, we do not plot these planes directly. So what we do with plane only, we project as a pole. So we plot only pole. Hmm. So, and this is represented in a point manner. So here a pole, what is a pole in stereographic projection? A vertical line that intersects the equatorial plane. Wrong. A point that represents the orientation of a plane. Correct, right? That is what this will give you, the orientation of a plane. So this is the correct. The point where the plane intersects the stereo net. Wrong. It's nothing related to do with the stress. Wrong. So option B is correct. Let's go to the next question. Which of the following best describes the relationship between a great circle and its corresponding pole on a stereographic projection? So the question is, which one of these four options will best describe the relationship between a great circle and its coordinate corresponding pole on a stereographic projections? Tell me. First, option A, the pole lies in the great circle. Option B, the pole is 45 degrees away from the great circle. Option C, the pole is 90 degrees away from the great circle. Option C, the pole is directly opposite to the great circle. So what do you think? Hmm. I will wait for 10 seconds so that you can think. Think. So we learned here that the distance between this point and the actual plane is 90 degree. The point lies on a great circle. It's not always true. It can lie anywhere in between. And of course it lies, but that is not a relationship between pole on a stereographic projection. The pole is 45 degrees away from great circle. No, we learned what? 90 degree. The pole is 90 degrees away from the great circle. This is the correct option. The pole is directly opposite to the great circle. No, this is wrong. So option C is correct. I hope you understand. Right? Let us move to the next question. When plotting the intersection of two planes on a stereographic projection, what features represents this intersections? Option A, great circle. Option B, small circle. Option C, point. Option D, a line. So this is not right. So the question is saying, suppose you have two planes, plane 1, plane 2. When will these two planes intersect? What will be intersection? A point, right? It will never be a great circle, right? It will never be a small circle. Will be a point. This is so option C is correct. Okay, let's move to the next question. This is interesting. So this is a match the following. So try to see, these are the symbols and this is the explanation. So try to match. We give you 30 seconds. Okay. Okay. So this is, what does this represent? So this is a strike, this is a dip, and this is deep direction, and this is the dip amount. So what does this consist? Vertical weight? It's not, right? Because the dip amount is 25. It's not a vertical plane. It's a horizontal plane. No, dip has 25. So this is not. Strike slip fault? No, it has not a 90-degree, right? Something like that. So it's not a strike slip. Is it a third state? No, it's not a thrust. It's a normal fault, right? It's a strike and dip. So option A. Okay. So this is how we measure a vertical plane. So this is a representation of a vertical plane. Huh? So vertical bed is marked by a long line intersected by a smaller line perpendicular. Huh? So this is representing a strike and this is dip direction. Hmm. Horizontal bed. So horizontal bed is this. So this is represented by plus. So we know in a stereographic projection, a horizontal plane would be like this, on the circumference. We discussed during the class. Hmm. So thus, this is a horizontal plane. So this is a strike slip. We know in a strike slip, what does it happen? In a strike slip fault, two blocks parallelly moves, right? This moves in this direction, this moves in this direction. This is what it happens, right? So this is the representation of a strike slip, and this is a strike and dip. And this is how thrust fault is represented. Thrust fault is represented by strike line and this shaded triangles. Huh? Shaded triangles. Okay. Nice. So we can see option A is strike and dip, option B is vertical bed, option C has a horizontal bed, option D is a strike slip fault, option E is a thrust fault. Got it? If you have any problems, if you have any doubts, please feel free to ask. Okay, it's about a fault. Let us try to see. So this is the symbol. This is again try to understand this again. The symbols. These are symbols are very important. Huh? So if you see here, this is strike. This is a strike, option A, and we have something like this. So this is, if you see, it has a it is indicating two deep direction, right? And dipping in the same directions. So we know if you see, look at a fault. This is a syncline fault, and this is a anticline fault. So anticline and syncline is basically how the limbs are dipping. Huh. So you can see the dip direction is like this and dip direction is like this. So both are dipping in a same direction. So these are called syncline. That is why option A will be syncline. And if you see option B, if you see here, it's dipping in this way, it is dipping in this way. So this is a representation of anticline. Hmm. Option C, if you see there, so this is the dip direction. Option C is like this. So this is the strike. It's dipping away. So it's very clear that it's an anticline, right? And one interesting to note here is there is another arrow. Arrow means what? It's this strike is also dipping. So what happens when there is a fold and the hinge axis is also plunged, right? So this is called plunging and decline. So if some mistakes happen, so this is one of the there are two normal fault. This won't be a normal fault. This will be one of there will be plunging syncline. This is a plunging syncline, right? So similarly, what will be if it's dipping here? So this is syncline we know, right? And this is plunging. So plunging syncline, syncline plunging. So this will be this, and this is a representation of normal fault. So this is how it represented. So we say important, symbols. So remember, try to remember this, symbols. They're very basics and very important, very to understand any topographical, map, geological maps, or if you go to the field, if you look at the pre-existing maps of any topographics, any structures, it's important that you learn to understand this symbols, geological symbols. Okay, let's move to the next question. It's related to Bruntons or clinometers. Which of the following components of the Brunton compass is used to measure the strike of a geological feature? So this is strike. Huh. So tell me which one is used to measure strike. It's a component, huh? Remember, this is asking components of a Brunton compass, huh? It's not some instrument, it's a component. So tell me. Option A is level bubbling. Option B is azimuth ring. Option C is clinometer. Option D is a side pin. I hope you have, gone through the lectures and understand what is and have seen, what? Brunton compass. Okay. Okay. So without delay, let me take you to a Brunton. So if you see here, so this photo has been taken from Google. So if you see, this is the top view of a Brunton compass. So if you see the components, important components are, this is also called bullseye, long label or clinometer. Huh? These are the slates, peep sight, it took lock magnetic needle, azimuth scale. This is magnetic scale. It's long edge, clinometer arm. So these are then the inside of this, the azimuthal scale. There will be clinometer arc. There is a clinometer scale. There is the two peep sight here and right side. This is the mirror. This is the window in the mirror. So to measure strike, what we do is we try to make this horizontal, the bull's eye horizontal. So we try to fit this bull's eye in the center of this, you know, bull's eye. So that is how we measure. So this is also called. So see, clinometer is an instrument. This is not option correct. Sight when is something which, you know, this if you look at this image. So there is a side wind, huh? So this will not be. This is not actually. So even this is also called side wind, huh? This slit window, this or this. So this is not used to measure strike. And what else? Azimuth ring. So azimuth ring is something that gives you, but that is not the main component. The main component is to make this horizontal zero, bullseye. So that is by this, the level bubble is the correct option. Let us go to the next question. When using a Brandon compass to measure the depth of a rock layer, how should be how should the compass be positioned? So to measure strike or dip of layer, you should know how to compass. How should the compass be positioned? The how we take how we measure the dip in strike. So it's here the question is about dip. So tell me. I have shown you this. If you have gone through the lectures, you must understand these processes. So please answer it. See, to measure a strike, what we do, anyone have any idea? Okay, let us read the options. The compass should be held horizontally with the clinometer reading taken value directly. No, this is not the correct. Okay, I'm not going to comment right now. Let me go through the other options. The compass should be held vertically, parallel to the dip direction, with the clinometer engaged. The compass should be held at an angle that matches the strike of the rock layer. The compass should be placed flat on the surface of the rock. So, what is the correct way? So, for example, suppose this is a plane. hmm, So this is a plane, huh? So you would like to measure the dip of this layer, huh? This layer. So what you will do, you will, so this is the compass you can see, right? So you put, you you make this and keeping this in the direction, dip direction, huh? So if you see, the compass should be held vertically parallel to the dip direction. So this compass, I will just draw a very rough sketch. So this is how it is should be placed. So this is the dip direction. So parallel to the dip direction we have kept it, and clinometers in gauge. So clinometers used to measure the depth, huh? The inclination. Nation. Hmm. So that is why option B is correct. It should be. It should be what? It should be in the parallel direction. This is incorrect. This is incorrect. This is incorrect. Huh. We don't measure horizontally. Horizontally, we measure the azimuth, right? We studied. Inclination is measured in vertically. Hmm. Let us go to the last question of today. Which of the following steps is crucial when taking an accurate strike measurement with a Brandon compass? So with Brandon compass, there are some procedures. So we should, before measuring, we should be very careful. So let us read. Ensuring that the clinometer is set to 0 before taking the measurement. Here, point to notice, we are measuring a strike. So in strike, clinometer is not important, and setting 0 is not important. Why? Because s- it is not something like weighing something to tear it to 0. No, it's not like that. Aligning the compass needle with the direction of the dip, it's also not true. We don't have to do these processes. Making sure the compass is level using the level bubble. So this is what we were discussing in the first question right here. That is very important that this bubble is in the center. Here, here. So this seems the correct option. Holding the compass perpendicular to the rock surface. This is used to what? This is not as important, because as the most important is until unless it is this indicates that this your is horizontal. Hmm. Your Brunton is horizontal, huh? And we know strike is measured on a horizontal surface, right? So to make it horizontal, to make sure our Brunton compass is, to make sure our Brunton is horizontal, we level the bullseye or level bubble. So this is terminology that is used for with some author, with some people. So make sure it is on the bubbles, is in the center of the bullseye. Okay, like this. This is the center. Okay. So these are the questions that I had kept for today. Thank you. Uh, so if you have any questions, please ask, raise your hand. Otherwise, we are going to meet next week. And in the next week, we will be discussing the primary and secondary structures, lithostructures, and we'll see different types of you know, secondary planes and lineations, different type of lineations in the field, and we'll study some sets related to that. So thank you once again for joining for the live sessions, and we'll meet again in the next live session, which is on Saturday, sorry, Sunday, 3 to 5 p.m. And so I would request all of you to please go and read, watch the lectures before coming to the sessions, and please try to solve the assignments that has been mentioned in the NPTEL as a course assignment. Okay. Once again, thank you. I would like to thank all of you and see you in the next session, live session.